Okay, folks, section 2.8, the reciprocal of a real number. I want to talk about something for a second. Is that all right, Kyle?
Yeah.
If I talk about something for a second? Before I get to this, because everyone wants to know, what's a real number? Aren't all numbers real numbers? Actually, no. Not all numbers are real numbers. Some of them are imaginary numbers. We call them imaginary numbers. Okay, they're not imaginary numbers. We need them for things like describing the way electricity runs through these lights to make sure that things don't catch on fire. Okay, we use imaginary numbers for that kind of thing. You don't need to write this down, but I'm going to use this space up here for just a moment. All right. Parker, J. What does this sign mean? It means square root. Parker, what's the square root of 25?
5.
It's 5, right? Now, you did say 5. Oh, look, I made a mistake. Oh, man. Since 93, and now I just ruined my average. Okay. All right. Now, do you agree that 5 times 5 is equal to 25? Do you also agree that negative 5 times negative 5 is equal to 25? Okay. Now, let me ask you this. What's the square root of negative 25? What number multiplied by itself gives me a negative 25? Nothing, right? Because if I multiply by itself, it's either going to be a positive times a positive, and that gives me a positive, or a negative times a negative, and that gives me a positive. So there is no number that multiplies to give me negative 25. Ooh. Let me show you this. I'm going to come back to this problem in just a minute. Okay? Let me ask you this. Let's do the square root of 4 times the square root of 9. Okay? Emily, what is the square root of 4? And what's the square root of 9? So when I multiply them, what do I get? I'm going to get 6, right? But watch this. What if I multiplied the square root of 4 times the square root of 9? I'm going to get the square root of what? Take a guess. 36. What is the square root of 36, James? 6. You can multiply radicals. This thing is called a radical because it's under a root symbol. You can actually multiply those things. Okay? You can't multiply a radical by a regular number, Clay. You can't do 2 times the square root of 5 and make it the square root of 10. Okay? They're separate. It's like not being able to add unlike terms. Okay? But if they're both under the same radical sign or root sign, then we can multiply. Now here's why I asked you that. Parker. If I can multiply radicals, do you agree that I can break them down and I can factor them? The square root of 36 also equals the square root of 3 times the square root of 12. Right? I mean, if I can multiply them, then I can factor them. So that means I can factor this. Well, you know what? I want to factor it into these two things. The square root of 25 times the square root of negative 1. Do you agree if I multiply those, I get the square root of negative 25? Okay, good. But here's why I wanted to separate them. Because what's the square root of 25 again? 5. Okay, I can simplify that. This thing has a special name. You just call it I. Okay. I stands for the square root of negative 1.
It's imaginary number.
It's an imaginary number.
So it's always I.
It's always I.
So it's negative.
Like this is a Greek letter, right? This equals 3.1415296, whatever it's 65926. What am I doing? All right, hey, give me a break. Okay, fine. Right, pi all in the same day. Well, you know when it rains, of course, right? Pi stands for this number all the time. This is another special number. Okay? E, it's 2.718281828. No,
Oh, then
it
B, but we didn't know that B.
You don't need to know that. Okay? You don't, hey.
For a second.
All right.